Hello and welcome to the second video on arithmetic sequences. Today we're going to look at applications of arithmetic sequences, including and as well as simple interest and flat rate depreciation, where we're going to write the rule for a number of situations. Let's get straight into it, and I'll just get a different color. The following table shows the number of students who attend a study session each week. Okay, as you can see, we've got that here. Let's actually put down a rectangle. Just cover up the question. Demonstrate that the study session attendance forms an arithmetic sequence. Arithmetic sequence. All right. Sorry, I'm a bit tired today. Okay. So this is what's locked in our mind about arithmetic sequences. So we need, in order to define an arithmetic sequence, we need two things. So we need a first value and a common difference. So let's check it out. Well, what is the first value? So we can either call the first value A or T1, and we can see that that is 10. And then if we're looking for our D value, we do the difference in these Y values. Say this is X and this is Y. And we can see that we're adding 4 each time. Adding 4. So the common difference is positive 4. Demonstrate that the study session attendance forms an arithmetic sequence. So we want to actually write these formulas if we can. Okay, so let's do it. I'm going to write the recursive formula. So I know to define the recursive formula, we need our T1 and we need the actual formula itself. Tn plus 1 equals Tn plus, so just substitute in that D. And remember that this means the next term is the previous term plus or minus that common difference. Sorry, that's a bit messy. That's all those little subscripts mean, the n plus 1 and n. So this side's bigger than this side. Okay, let's check this out. So we've written one of the formulas. Okay, so we've written the recursive. May as well write the rule for the nth term too. So you'd get full marks just for writing that, but I'll also show you if you wanted to substitute into the nth term. I'd write the general formula first. T1 plus n take 1 times D. And then we just substitute in the things that we need. You leave in the n's because it's a function with n in it. T1 is 10 from over in our little data table, plus n take 1 times our other key bit of information. Let's move that over. And then you usually leave the rule for the nth term in simplest form. So I would expand those brackets. 10 plus, if you put, I'm going to rewrite it like that. And then we just use that crab claw to expand. Reach out to the first number, 4 times n. Reach out to the second number, positive 4 times negative 1. Take that sign out the front. Okay, so we've got positive 4 times negative 1 is negative. Positive times a negative is negative. Simplify further. Collect those normal numbers. 10 take 4 is 6. So that is what you could write. You have demonstrated that it forms an arithmetic sequence. Find the rule and use it to predict the number of people attending in week 10. Okay, well, we have found the rule. The rule is this one. So let's do it. Let's actually get rid of this box. So part A is done over here. Let's just write that. And B. So let's write our rule in most simplest form, the rule for the nth term. Tn equals 6 plus 4n. We need to find it in week 10, which means that n equals 10. Okay, so substitute in n. 6 plus 40, 46. So that is term 10, and you can put a box around it just to make sure that your teacher can find where your answer is. And let's move to the next one. Okay. The following table shows the depreciation of an electric car's driving range from a full recharge. All right, so we've got age here starting at 1, just like the last one was starting at 1. And we've got the range in kilometers. So in the first year of having this electric car, it travels 600 kilometers on a full recharge. Then year 2, a little bit less. And it continues to depreciate over the years. So its performance gets worse. Determine the rule for the range of the electric vehicle after n years of age. Okay. The rule means this rule for the nth term. So let's just write it straight down. Tn equals T1 plus n take 1 times d. And we have our first term. Our two important things with arithmetic sequences are T1 and D. So T1 equals 600. D is the common difference. And we can find that. We can just subtract consecutive terms. So you could do that. And we're going to find that D is negative. You can always find it from the sequence itself, where you can see that it's subtracting 20 each time. And we can quickly find the rule by just subbing in our values for arithmetic sequence, which are important, T1 and D. So 600, leave the n's in. And then we are going to choose to rewrite it with the constant at the front of the brackets to make expanding easier. And then take that sign at the front. So crab claw, negative 20n. Negative 20 times negative 1 is positive 20. And then leave it in simplest form. To collect those like terms, 600 plus 20 is 620. Take 20n. So you're just finding the function Tn in terms of n. Leave those n's in. Next question. All right, well, what is this? Oops. The amount in a bank account earning simple interest or owing on a loan paying simple interest. So we're just introducing a new little concept now. So simple interest, the amount in a simple interest bank account is this formula. Now D can't be simply calculated as T2 take T1. Now D is I times P. So D in the simple, using it for simple interest, D is the amount of interest paid per year. And I is the interest rate per year converted to a decimal. So this little I. So most people usually know that P is the principal. They can quickly see that, recognize that from our formulas, A and P. But yeah, this D is a little bit different now. And on this slide here, we just have what it looks like. So arithmetic sequences look like that. They start at term 1, whereas in applications of some arithmetic sequences, they might start at T0. So that very initial value, they'll have an initial value. But yeah, so we will see more of that. And that's just a little bit more on it. So the amount in the bank grows over time due to that little common difference of interest. So this is a simple interest graph. That's our formula we use. And you might also have depreciation. And depreciation can also be calculated like that too, but we're just going to get into some questions and it will make more sense. Okay, let's get a different color. Maybe pink. A simple interest investment of $4,000 has an interest rate of 8.4% per year. Write down the rule for the value of the simple interest investment. So we've got, just underline some keywords, $4,000. So I know that that is going to be my principal, right? That initial value. The investment of $4,000 has an interest rate of 8.4% per year. Write down the rule for the value of the simple interest investment. So let's make a little data table. We're given that P is 4,000. We are given that there's an interest rate of 8.4% per year. And we know we can use that in something. So look at that. The interest rate is written as little I. 8.4% per year. And in order to use it in our calculations, we convert this to a decimal. And how do we convert it to a decimal? We divide it by 100. So we will have, move that decimal, 0.084 per year. And then looking at this, we know that we need to use our simple interest formula, which is A equals P plus ND. And this isn't actually given on your formula sheet, sadly. But it shouldn't be too hard to remember, even though I keep having to flick back. So let's check it out. So we just want to write a formula A in terms of N. Now remember, we need to calculate D here. All right, so we've got P. We need to calculate D. So I'm just going to write it over here. D is I as a decimal. The interest rate is converted to a decimal times the principal. And into our calculator, careful to put that 0 in there too, 0.084. 336. So what this means, if we come back to here, that's that value. That's the interest amount in dollars per year. That's the formula for interest per year. You do the interest times the principal. So that's how much it's increasing. And now we can just going to put a box around that because I know I need it. And now we have everything to write our formula. So P is 4,000 plus, leave N in. And that is our rule. Maybe you want to rewrite it with the coefficient out the front. But that's our rule for that one. So let's move on. The value of a boat is flat rate depreciated in value by 10% of, so I'll just underline as we go actually. So flat rate depreciation, 10% of its initial value every year. So depreciation means going down in value. Initially, it was valued at 30,000. Find an expression for A, the value of the boat after N years. All right. So anything simple interest or flat rate depreciation, we are going to use this formula. But this time, it's going to be P take ND because it's going down in value. It's depreciating from that initial value. And again, notice that we have a percentage here. It's going down 10% of its initial value every year. So we can use this. We need to calculate D this time. D equals I times P. They're the two little bits we need. And let's write down a data table. So initially it was valued at $30,000. Initial value means P. So got P now. And it looks like we have to actually find that value that it's changing by every year. We need to calculate it. So we're going to calculate D. 10% as a decimal. Let's actually put it over here. 10% per year is 0.1. Move that decimal 2 places to the left. And let's chuck it in. 0.1 times 30,000. And so in other words, 10% of 30,000, which I feel should be 3,000. And I should trust myself, but I'm putting it in my calculator. Yes, it is. Great. So let's put a box around that. We'll need it. Now we have D. Straight into the formula. A equals P take ND. 3,000 take N times D, which we just calculated. And I have missed out a 0. It should be 30,000 for the principal. And they just want an expression A after n years. So you leave n in the equation. And just rewriting it with the coefficient out the front. And that's as simple as we can get it. Okay. Now, I've written a little note here. Compare with page 43. Let's have a look. And then, so if sequence starts from T1, we substitute into this. Remember that rule for arithmetic sequences? This one, the rule for the nth term that has the n take 1 in it. Whereas if the sequence starts from T0, we use this formula, P plus or minus ND. So the only difference is this n and n take 1. But let's check how we can compare this with page 43. So remember this formula here. Okay. Anything that starts at T1, you're going to use this rule for the nth term. So see how these started at T1? And this is also a depreciation table, but a bit different. So the following table shows the depreciation of an electric car's driving range from a full recharge. And it starts at year 1. Whereas these back here start at the very time you make your investment. The very time that you make your investment initially. So that's where you're going to use just the n formula. So lock this in your mind. If the sequence starts at T0, you use this formula. If it starts from T1, use the nth term formula. Let's keep going. All right. The value of a food truck with purchase price $46,000, let's underline as we go, is depreciated by $300, so goes down in value for $300 for every 1,000 kilometers traveled. Write a rule for the value of the delivery van after it has traveled n kilometers. So we actually, let's make a little data table. The purchase price at time 0, when you pick up that truck, not after a year or whatever, it is $46,000. It goes down in value by $300 so we know that D is going to be negative, for $300 for every 1,000 kilometers traveled. For every means divide. Means divide or per. So this is how I translated mine. So 300 for every 1,000. Because you want to get it into 1 unit per 1 year. Let's check out back here. You want it for every year. Oops. Every year it's going down. You want that. So we've got it for 1,000. Oh, for every kilometer, sorry. We want it for every 1 kilometer. So notice the units of this. What do you think the units of D are going to be here? Just while I calculate it. 0.3 dollars per kilometer. That's the units of, so 30 cents per kilometer is how much the value will go down. And because we're given an initial value, we know to use A equals P take ND. And we can quickly write the formula. So we just need P and D, which we have. Okay, so D is sort of like is the gradient, I guess. And yeah, this is a key question students struggle with, but for every means divide. Okay. So our P take ND. P is our initial value at time equals 0. Take N times 0.3. And then just leave it in a little bit simpler form. And that's where we're at. For every means divide the numbers. Okay. And again, I've said some application problems, you need to decide which formula. All right. So either the N take 1 or the N. Almost done. Sorry. Okay, let's get a different color. To make up a set of notes, Officework charges $4 for the binding, $4 for the binding, and an additional 5 cents per page. Write a rule for the cost of making up a set of notes with N pages. All right, so if you go to print out these notes, no matter what you do, even before you're binding any pages, you are going to pay a fee of $4. Now let's look at what it looks like. So T naught equals $4. And an additional 5 cents per page. So additional 5 cents per page should be thought of as the common difference. But notice that we've got dollars and we've got cents. To put them in the same equation, we need to convert them to 1 unit. So 5 cents, to convert that to dollars, we are going to divide by 100 because there's 100 cents in $1. So you could look at it like that if you wanted. Okay. Actually, that probably makes it more confusing. 5 divide 100. 0.05. And then we've got them both in dollars. Write a rule for the cost of making up a set of notes with N pages. So just write the general formula first. We know that D is positive. And it's starting, it has that very initial value before you do anything. That's what you're charged. So A equals P plus ND. P is 4, that initial amount. Leave N in the equation. And D should also be converted to dollars. And that's what we've got. And I've said compared to page 42 and 43. So let's come back. So remember this formula. So these ones explicitly say that it starts at this first time period. If it started at 0, you would use the formula that we just used. But these start at 1, so that's why we use the nth term formula, that N take 1. Nearly done. A cordial flask contains 20 litres of cordial. Cordial is served in 200 milliliter cups. Write a rule for determining the amount of cordial in the flask, AN, after n cups of cordial have been served. Assume each cup is completely filled. All right, there's no other questions to this, but let's check this. So it helps to underline keywords, or it just goes in a big blur. So it initially contains 20 liters of cordial. T naught, before you even pour anything, is 20 liters. Now, I'm not sure what this bit means yet, but I know that we need to have consistent units. So 200 milliliters to get to liters, milli, divide by 1,000. So 0.2 liters. Write a rule for determining the amount of cordial in the flask after n cups of cordial have been served. So we start from T0, so we're going to use this. Now we need to determine, are we using A equals P plus ND or A equals P minus ND? So think about this cordial urn, this cordial flask, and it's being poured into smaller cups. So it's being poured, it's losing liquid. Losing liquid, so that means our D will be negative. So that's why we choose take ND. You're pouring out from that initial volume. All right. So we've got an initial value, 20, take N times our D, which was negative 0.2. Need to have consistent units there. Now this looks a little bit different. Negative N times negative 0.2. Negative times negative, positive. And that is going to be what we use for this. And then let's quickly get through this next question. A charity initially starts its fundraising ball with a $2,000 donation. Again, that word initially. They sell tickets for $100 each. Write the charity's earnings after selling N tickets as a recursive relationship. Okay. Let's put down our little data table. Initially starts with a $2,000 donation. So before anything's even done, they get $2,000. T0, 2,000. They sell tickets for $100 each. And we want their earnings. We want Cn as a function of n. Now we have a T0 value, so I'm just going to use this formula. Let's write it over here. And there we need to think whether we're plus or minusing. It is going to be plussing because we're raising funds. So we're making money. We're not losing anything, we're making money. So A equals P plus ND. And so I always just put P is there. And we need that common difference. D is 100. And now let's look at this. That's asking for a recursive relationship. So I know that with a recursive relationship, I have to have an initial value and a D value, which we have. And we've just got to work out how on earth we write it. So recursive, always start by writing that initial value. Okay. The initial value there. And then the comma. And we just need the n plus 1 equals something. In terms of, how do we do it? This is how I remember it. Tn plus 1 equals Tn plus D. That's a general formula. You might also see it written as like this. Cn equals Cn take 1 plus D. It's just which one you choose. Okay, they're the same thing. Okay, and we got T naught is 2,000 and we just substitute in D. T was 100. And that's what our recursive formula is defined by. So I might just get rid of all those circles. But yeah, you could either write it like that. Oh, they're also saying write the charity's earning CN after selling N tickets. Oh, yeah. So it might be, I think that's will do. I do get a little bit confused with these ones. Actually, let's put it into this formula. So, sorry to do this at the 30-minute mark. CN equals CN take 1 plus 100. And that's where we'll be looking at. Okay. And very final part of the question. How much money will the charity have after selling 200 tickets? After selling 200 tickets. Well, let's delete all this first of all. All right. Using this recursive formula, CN equals CN take 1 plus, well, actually, see how it says after selling 200 tickets? That's going to be a lot of using that recursive formula. So we actually want to use this one. Now, we want the rule for the nth term. A equals P plus ND for part B. And we know that we need P and D to define it. P was 2000 plus N times D was 100. So that's our general rule. And now let's substitute in after selling N tickets. So sub N equals 200 tickets. And let's have a look at how much money this charity raises. How much they can spend on this event. 2,000 plus 200 times 100. They've got $22,000 to spend on this event. So they could make it pretty nice. Have it a nice venue or have really nice food. Choose. Okay, I hope that helped, and I will see you next time.